is Coatesville, Pennsylvania, 38 miles west of Philadelphia. Population, 20,000. Early morning, looking out over this valley and still sleeping town, it looks like any American town. But Coatesville is a steel town, the home of Lukens Steel Company. Here since 1810, the townsmen have made iron and steel and run the shops and mills. They rolled the first boiler plate in America, and today they run the world's largest plate mill. Many are descendants of the early founders and workers. They live on the hills and the valley's edge near the plant. One of these steel men is John Miller. He is husband, father, worker. John is in the fourth generation of a family of iron and steel makers. He is boss roller on the world's largest plate mill. There is something fine in the way Mary, his wife, understands his feeling about the job he does and about carrying on a tradition. Theirs is a clean-cut and purposeful way of life which they share with their children, Barbara Jean and John Jr., who can hardly wait until he's old enough to run an ingot chariot for his dad at the big mill. The steel company, lifeblood of the town, has fed John Miller and his family before him. John's great-grandfather was helper at the old boilerplate mill. Back then, the mill was run by water power, but they rolled boilerplate, the first in America to roll it. And today, John rolls out the widest and heaviest plates in the world. Making steel plate is in his blood, and he's good at it. He's proud of his job. And his family is proud of him. John doesn't work alone. He depends on teamwork, on thousands of men all through the plant, working together to make steel. From the raw materials into molten metal, from molten metal into ingots, from hot ingots into steel plate for industry. Morning, Max. Max walks to work with John most every morning. He runs a charging crane at the open hearth. His job on the team is to put raw materials into furnaces where they are melted down to make steel. Hi there, Pete. John knows Pete well, although he doesn't see much of him at work. He talks to him often on the intercom. Pete is a heater at the big mill soaking pits. He sends John hot ingots to roll. Here's Ray, who operates the new 120-inch plate mill. Ray and his crew hold a record for the number of plates rolled in a day. A little late this morning, Tom. Tom works in the metallurgical laboratory down in the heart of the plant, where steel is tested and analyzed. 5 men of steel, a part of thousands in the steel-making team. Perhaps John has such a great interest in the plant because it is part of him that has been passed down through generations. Nearly every morning he takes this walk by himself through the yard. He likes the feel of it. The ingot yard, where ingots of many sizes and different grades of carbon and alloy steels are cataloged. The scrap yard alongside the open hearth, on the way to his mill. Here are the basic raw materials: scrap metal, limestone and pig iron waiting for the furnaces, to be melted, to be cast into ingots, to be heated and rolled into steel plates for industry. This is it, the 206-inch mill, the world's largest plate mill, 3 stories high with twice as much of it below the floor. John Miller's crew, tablemen, screwmen, gauger, plate men, they all work together and make the big mill work for them to roll steel ingots into the lightest and heaviest plates in the world. Ingots like this one being stripped of its mold, 64 tons of steel. Many steel makers have labored to create this, the largest ingot ever made for rolling. Now others must work on it. The 9-ton hot top has to be cut off. It contains the impurities that rise in the mold when the molten metal is cast. Men with long oxygen lances add their hands to the task of getting the ingot ready. Ready for peat at the big mill's soaking pits, where ingots are heated white hot for John Miller to roll. Heat makes a final check of precision instruments that control and record pit temperature. John has the heat sheet, a complete description of the plate he'll roll with its dimensions. "56 tons, soaked 18 hours in deep white heat, 2,300 degrees Fahrenheit, just under melting temperature. An ingot for the big mill, the only mill in the world that can roll it." On a signal, John's tableman moves 56 tons of hot steel just so. The screwman, with a push of a lever to the 100th of an inch, sets huge rolls just the right distance apart. Wet burlap and men to throw it on the right spot to clean the iron oxide scale from the ingot. To improve the physical properties of the steel, John turns the ingot sideways to roll across grain, to squeeze the internal crystalline structure of the hot cast metal into a new and tight, uniform grain pattern, to make a plate of higher tensile strength and greater resistance to fatigue and shock. The ingot has been worked down to a slab. It's ready for the table crane, ready to be turned over. Thick and heavy slabs like this one require special treatment to clean off flakes of scale still clinging to the undersurface. So it is turned over before final rolling. In final rolling, John gives special attention to finishing the surface. His plates must be smooth. His men know what to do. Rock salt, water, steam, and tremendous pressure of the rolls combine to explode scale from the plate. Skilled steelmen who work against time to roll out 56 tons of steel before it cools to critical range to make one of the heaviest and thickest plates ever rolled. Wherever this plate goes, as a huge gear or a base for heavy machinery, it's going to have John Miller's mark on it. John knows that his is only part of a total job. There are the men at the open hearth who make the steel, and the workers at the scrap yard who sort raw materials for the furnaces and operate the gantry cranes and electromagnets to move scrap metal to the open hearth charging cars. All of this goes to one furnace to make one heat. Basic raw materials of scrap metal, limestone, and pig iron to make 130 tons of steel. Here is Max, moving up. Furnace 24 is in his group. Max jockeys the charging cars in place before each door in the line. Lifts each pan, spins it over and around and back. Max spreads raw materials so they will melt into an even heat of boiling steel. Steel to be cast into molds that form ingots for the mills. Other steel workers behind the furnaces, down in the open hearth pits, begin the setup for the molds. From here on, the labor of Max and the others making the heat is in the hands of this worker, because down that center runner will pour tons of molten steel. Down the center runner, into channels in the base plate, to flow up into many molds simultaneously. Out of thousands of molds cataloged according to different sizes, the right size required to produce the finished plate is loaded for the open hearth pits. To the setup. Carefully centered over the channel in the base plate. Workers setting up to tap the furnace, craning in the ladle, making ready for 130 tons of molten steel. Up on the furnace floor, melters, like Max's boss, keep close check on the progress of the heat. The inflexible rule of the open hearth is exact quality control. His men understand and follow that rule. They check and recheck a heat by tests from the molten bath. Tests to maintain exact chemical specifications. A bath sample is the key to all that will follow. This miniature ingot and slag from the heat are analyzed in the open hearth laboratory, where technicians with delicate instruments determine whether additions of iron ore, carbon, manganese, nickel, silicon, or chrome should be added to the heat, and how much. The melter is ready to tap the furnace. His crew ready to burn out the plug and to ram it through. Here it comes, molten steel, 3,000 degrees Fahrenheit. Measured additions that the lab has specified: aluminum, manganese, and more silicon. And carbon in just the right amount. And an alloy steel of calculated quality is made. Steel filling up the ladle, and non-metallic slag floating to the top and spilling over, making room for 130 tons of steel. Down the center runner, into channels in the base plate, tons flowing up into molds. The labor of steelmakers taking form that John, Pete, and Ray, and thousands more in the steelmaking team can work and roll and shape. Ingots like these for the 120-inch mill. Ingots for Ray to roll out into steel plate for industry. This steel, originating in the laboratory, its internal structure, a combination of metals, alloys, was designed, engineered to do a specific job. So every ingot is cataloged and numbered before they are sorted for the mills. At the 120-inch mill, Ray is kept busy rolling plate after plate of alloy steel. He is finishing one now. Ray's mill operates like clockwork. From the soaking pits, where automatic tongs pluck out a hot ingot with the ease that Ray would pick up a cigarette, all down the line, the whole 120-inch mill is geared to precision production. Down the tables to the slabbing mill, where ingots are broken down for finished rolling. Grooved rolls bite in and break up scale. Cross-rolled to improve physical properties, and then measured for plate width. A clean slab down the tables to the 120 for Ray to finish rolling to thickness and length. Smooth rolls controlled by the touch of a button, the twist of a dial. Stretch out the plate in the direction it is rolled. From the first day that Ray put his hand to these controls, he has felt there is no finishing mill anywhere that can touch the 120. A lot of streamlined power. Power at his fingertips. She is queen of the rolling mills when it comes to rolling light gauge plates to exceptional flatness with smooth plate surfaces and very close gauge tolerances over the entire plate. Men and machinery keep the plate moving to make room for plates on the way. On down the line, through the straightening rolls, to flatten every ripple in the plate. All along the way, through the heat-treating furnace to the finished plate, the quality of steel, its physical properties, tensile strength, hardness, and grain structure are carefully controlled to achieve the calculated result of long research in the laboratory. Finished plates on their way to inspection. Ray and the men down the 120 line can't help being proud of their mill and the job she does. Plate after plate has rolled down the tables for inspection without a surface defect, smooth and clean on both sides. The layers out, men who check, number, and measure every plate to dimensions on the order sheet. Between these men and the layers out at the 206 are handled the greatest range of plate sizes in the world. From quality plate, samples are cut for Tom to bend, twist, and pull apart. Tests to double-check the physical properties of finished plate. To find the yield point. How elastic is it? How about its ductility? What is the ultimate tensile strength? How far will it stretch? And how many thousands of pounds pull before it breaks? Tom has worked with steel for a long time. He and metallurgists working with him represent the control from the open hearth to the finished plate. These thousands of test pieces are from steels designed for toughness, strength, ductility, and drawing qualities, for resistance to sub-zero and elevated temperatures, corrosion, pressure, abrasion. Many types of carbon and alloy steels to do specific jobs. And there is still the need for research on new alloys to supply ever-changing demands of industry. Tom is one of many steelmakers helping to shape the future. He keeps the record through every step in the progress of an experimental heat. Tom is guardian of an idea, a metallurgical step ahead toward industrial progress, of an alloy steel beginning in the laboratory to supply industry in quantities of tons upon tons of quality steel plate. Plates like this one from John Miller's big mill, steel designed to withstand shock, stresses, and impact. Steel for locomotive frames, flame cut 3 at a time from a 55-ton plate. Steel shapes for industry. And bench shapes, steel to resist fatigue for machinery frames. Pressed shapes, designed to withstand heat and pressure, boiler domes for locomotives. And heavy shapes, 25 inches thick for power gears. Spun heads, the largest and heaviest in the world for pressure vessels, shaped from wide plates like this one that only the 206-inch mill can roll. One plate to replace 2 or more of standard widths, saving fabricators time and money. Men and machinery all through the plant make the steel and form the shapes. Skilled men like John Miller. And special machinery. The world's largest plate mill. To roll the widest plates ever made. From all types of steels, including stainless and other metals, such as aluminum, copper, silicon bronze, nickel, Inconel, and Monel. As well as steels clad with nickel, Inconel, Monel, stainless, and silver. The big mill is a tool serving all industry, and John Miller runs the big mill. He makes the plate, extra wide plate for the petroleum industry that provides man with fuel to feed the furnaces in his plants, fuel to keep him warm, and to run his automobile. Extra wide plate for locomotive boilers and fireboxes, for streamliners that speed on their way to shorten man's time between great cities. Steel for huge generators and gears, to harness power, to move the machinery of man's industry, and to bring light to his streets and homes. Heavy steel to support the engineering feats of man. Thick base plates and huge expansion joints for bridges, to span wide waterways for his traffic and commerce. And extra wide plates to make ships, to carry the products of man's industry to all parts of the world. John Miller and others like Tom, Max, Pete, and Ray, from the research laboratory on through the entire Lukens plant, many steelmakers have labored to bring this plate into being. Every day, John Miller does his job. And more, he adds to a tradition born of an ideal to pioneer for progress, begun at Lukens more than a century ago, when the first boilerplate in America was rolled. Today, that same ideal is continuing to serve and shape the growth of industry and America.